Hi guys, this is Mohammed Talib. So I have made this project named Churn Prediction in Telecom Industry using Logistic Regression. As a data science intern at Code Cloud, I have made this project and let's get started. So see, I have imported all the necessary library which we are going to use in this project, like NumPy Pandas. Then importing the dataset. So for you guys, I have provided the link in this video's caption. You can go from that link and you can download the dataset. Okay, here we are going to see the head. So there are 5 rows and 21 columns. Shape of that data is 7043 rows and 21 columns. Okay, so this is just matplotlib inline. We can only use this in Jupyter Notebook. Okay, uh, this is an histogram. Okay, so there are female. The count is 2015, 2549 female, which haven't done the churn, and 939 female which have done the churn. Similarly, you can see there are 930 male which have done the churn, and 2625 male which haven't done the churn. This is a bar provided by Matplotlib library, then a histogram as well. This is a pair plot which is provided by the Seaborn library. Now cleaning the data. So we are going to remove the gender, customer ID, temperature because it is not useful. Okay. Uh, Here we are dropping the data. Column name, gender, customer ID, temperature. Then picking the head. Okay. As you can see here, gender, customer ID, temperature. So, so see this total charges is an object data type. So we have to change it into either integer format or float format. So why this is in an object format? Because it contains a space. See, what we have done is replace that space into NaN. Okay. Then we are changing that total charges into numeric format. Okay. So you can see that this is now had been changed into a float 64. Okay. So see, now we are checking is null dot sum. It means that if there is an any null value, it just showed here. But no, everything is zero. So our data is clean. Okay. Clean means there is no null value in the data. Okay. So we are checking the okay. There are only two unique values in chunk. Means only yes or no. Okay. This is a bar chart, okay, with respect to every column like senior citizen, partner, dependents. Okay. Then what we are going to do is changing that yes, no into one and zeros because categorical data cannot be fed directly into the model as it is logistic regression and yes and no is going to be our problem. So we are changing it into 1 and 0. See, such a 0, 0, 1. Okay. Now we are generating the dummies as I have already told you. Yes and no. You can see yes, no, yes. No. It's going to change in 0, 1. Okay. See, 0, 1, 0, 1, 0. Now we are checking the correlation between all the data. Okay. See, this is the correlation. Now see, high churn seen in case of monthly contracts and no online security, no technical support, first year subscription and fiber optic internet. Obviously, if a company haven't provided me my online security and not providing any technical support, I am going to churn into different networks. as same. Low churn is in seen in the case of long-term contract subscriptions without internet service and customer contracted for more than 5 years. Okay. Factors such as gender, phone service availability, and number of multiple lines have almost no impact to them. Okay. This all can be seen from where? From this correlationship, you can get CORR and then two parentheses. Okay. Now we are checking the correlationship between all the columns. The churn, the first three until phone services hyphen yes, all the below columns has at least minus correlationship. So we are going to consider these two after our churn prediction. Okay. So we are here we are parting the data into two x, okay, and then y. Y consists either a customer is going to churn or not, like 0101. Okay. Now variable imbalancing. See here y contains 5163 0 and 1869. So it definitely generating wrong result. Okay, so see uh, in the y data set, the zero, the churn zero has 5160 rows and one has 108 1869. So what it tells, it generates the variable imbalancing. So to deal with it, we are going for a library which is SMOTE. Okay, so we are fitting the x and y and see. Now the value count has been changed. Now 5163 rows which tells 0 as churn and 5163 also rows which tells y, sorry, 1 as churn. Okay. Now variable imbalancing has been totally finished and now our data has been changed as it contains 10,326 rows and 42 columns. Okay. And now we are going to import logistic regression from linear model as it is a linear model. Splitting the data y train x test y train y test. Now this train test split is a library from which is provided by sklearn. Okay, fitting our x train y train into logistic regression. Okay, then predicting the testing test data. Okay, checking the accuracy 78.46. That is good. Okay, now what we are going to do, we are going to fit that data where we have used that smooth library. Okay, to deal with imbalancing. Now see 83.78 accuracy score. Now without using the imbalancing, we get the score of 78.46, and after dealing with imbalancing, we are getting the score of 83.78%. See, even a little thing can change that whole accuracy level. Okay. Now we are going to use a standard scaler for standardization. Okay. Uh, so now see the accuracy score has been changed into 84.12%, even greater than before. Okay. Done. Thank you so much for listening.